Hey, everyone! Welcome back to the channel. In this video, I'll show you how to use a 15A 400W DC-DC boost converter, step by step, from wiring to testing. This module is super useful if you want to step up voltage, for example from 12V to 24V or even 36VV, for powering LED lights, amplifiers, or other DIY projects. Let's take a closer look at the module. Input terminals, VIN, for power input. Output terminals, VOUT, for power output. Adjustment potentiometer to control the output voltage. Coil inductor and heat, sink for efficient power conversion and cooling. It's a high-power 400W module, capable of handling up to 15 amps. That's pretty strong for small power projects. Start by connecting your DC power source to the input terminals. You can use a 12V battery or a DC power supply. Make sure the polarity is correct. Red to VIN, black to VIN. Before connecting anything else, use a multimeter to monitor the output voltage. Now connect your multimeter to the output terminals. Use a small screwdriver to slowly turn the blue potentiometer knob. Turn clockwise to increase voltage. Turn counterclockwise to decrease voltage. Example: if your input is 12V, you can boost it to 24V, 36VV, or even up to 50V, depending on your setup. Once the voltage is set correctly, connect your load. This could be a LED strip, a DC motor, or even a hi-fi amplifier board. Make sure your device's rated voltage matches your output to avoid damage. Now turn on the power and watch the converter in action. Because this module can handle up to 15A, it can get hot during heavy load. So always use a cooling fan or proper airflow. Don't exceed 50V input or 60V output. And never touch the circuit while powered. It can deliver high current. Let's do a real demo. Here I'm powering a 24V amplifier board using a 12 battery. As you can see on the multimeter, the output voltage is stable and efficient. This setup is perfect for portable audio systems, car upgrades, or solar DI projects. Before we power anything on, safety first. Make sure your power source is stable and within the correct range. The input voltage should be between 8.5E and 50V DC. The output can be adjusted anywhere from 10V to 60V DC. For today's demo, we'll use a 12 DC power supply. Connect the red wire to VIN and the black wire to VIN. Double check your polarity before powering on. If you reverse the connection, you could damage the module. Now let's learn how to adjust the voltage. First, connect your multimeter to the output terminals, VOUT and VOUT. Use a small screwdriver to gently turn the potentiometer knob. Turning it clockwise increases the output voltage, and turning it counterclockwise decreases it. Do this slowly while watching your multimeter reading. For example, if we input 12V, we can gradually raise it to 24V or higher, depending on what our project needs. This step is essential. Never. Once your output voltage is set, it's time to connect your load. In this example, we'll power a 24V LED light strip using a 12V battery. Connect the LED positive wire to VOUT and the negative wire to VOUT. When you power on the system, you'll see the LED light up brightly because the converter is boosting the voltage from 12V to 24V out. You can also use this setup to power a DC motor, a car amplifier, or even charge batteries at different voltages. The key is to match the output voltage to the device's rated voltage for safe operation. Now let's talk about safety and efficiency. Since this converter handles up to 15 amps of current, it can generate heat, especially under heavy load. That's why these heat sinks are installed, and you can even add a small cooling fan if you plan to run it continuously. Try to keep the temperature under 85 degrees C for long-term reliability. Also, never exceed the maximum input voltage of 50 V or the maximum output of 65 V always. Test your setup before connecting expensive equipment. Good ventilation and careful adjustment can make this module last for years. Many beginners make simple but costly mistakes when using boost converters. Here are a few to avoid. Reversing polarity. Always double-check input and output connections. Adjusting voltage while connected to load. Always adjust before connecting your device. Overloading the converter. Never draw more than 15 amps. No cooling. Always use airflow if running at high power. By following these basic rules, you'll avoid short circuits and damage. Let's quickly review what we learned today. A boost converter increases DC voltage from a lower to a higher level. We covered how to identify input-output terminals, adjust voltage safely, and connect a load. This 15A400W module is great for DIY electronics, Arduino projects, battery charging, LED systems, and even audio amplifiers. Remember to always check your voltage, use cooling, and stay within the safe limits. Thanks for watching. If you found this tutorial helpful, please like this video, subscribe, and share it with other makers who love electronics. See you in the next project, and keep building, keep learning. 1.